Okay. Hello, everybody, and welcome to today's device management interface call. Thanks for joining. As usual, the call is public and recorded and will be shared on YouTube. So please be mindful of the comments that you make on the discussions we have to make sure that they are public information. So first topic of the day is the fact that we have a release of the device management interface. I've tagged a 0.9.0 release. I've tagged it as so because I didn't want to do a 1.0 because we might want to straighten out a few things while we do the implementation. Especially given the fact that I know the team from Radisys and is building an open source implementation of the DMI on top of BBSIM. So my plan was, as soon as we have that working and we can officially prove in an upstream open source way that this works, and we have an exemplar to show it with, we're going to tag the 1.0. So, but I wanted to, in accordance with Amit and Holger and other people that I've discussed it with, I wanted to tag an initial release to have a fixed point in time, also before we added any logging to this component. So you can find it at the link here. You can just go there, and the source code and the zip file. And you can also check out the tag, and there you can find the interface as is. There's a minor problem that I'm aware of, which is that the Python PyPy packages are not uploaded. That is because there was an issue with Python 2 being end of life, and we were still using some Python 2 stuff. So what we are working on right now at ONF is to upgrade all the infrastructure to Python 3. We do have the patch working. We just hold it off merging it yesterday because of the 2.5 release. So we're going to merge it most likely today or tomorrow, and I'm going to retrigger the build for those PyPy packages, and we're going to have the 0.9.0 packages also on PyPy repo. So, any questions on the release? No? Okay then. The next topic is a very, very important one, and something that I really very look forward to. It's a demo from Holger at Adtran, showcasing us their implementation of the DMI interface on top of their device manager on real hardware, with showcasing the capabilities and the APIs of our interface that we're building. So, Holger, do you want to take over the screen and give us a demo?
Yeah, sure. Thank you. Can you see my slides?
Yes, perfectly fine.
Okay, great. Yeah, thanks for having me. For those of you who do not know me, my name is Holger Schulz. I work for Adtran in Berlin, in Germany. I have been working with Robert Barr, my colleague, for the last, 3 months about implementing this new device manager. We're both in Berlin, but we're both currently in home office, and I think haven't seen us for half a year or so. I want to talk a little bit about some basics about the design, what it is, how it works with external components and so, and then speak about what we have, or which parts of the interface we have already implemented, and then, as Andreas told you, show a demo in our lab with a real OLT. So I want to start first about some basics. So it's implemented in Go. It's a single Docker container. We are deploying it using Helm. So this is everything like Volta and so is also done, but it's very much self-contained, which means that you don't need much when running our device manager. It has some external dependencies. One is Kafka. Kafka is used for pushing events for alarms or metrics. And we will use etcd as a database for storing state of a device manager. So state can be which devices are managed and some configuration for alarms, for metrics, and so on, so that even after a restart of the device manager, it will automatically reconnect to configured devices. In principle, it has a very small footprint. It's not, I mean, it doesn't do very much, so it's not really that big. And this is a short diagram or small diagram which shows a little bit about the internals. So we're using something I call services, which are basically processes. So this blue box in the middle, this is a device manager. And as you can see, we have several processes implementing certain functionalities. We use some internal messaging. So we're not using Kafka, for example. So we are not relying on an external Kafka, but we're really using something internally. On the right-hand side, you can see an header and OLT, and you can see that there's a netconf connection to that OLT. So everything we do is via netconf. And we have a process called session handler, which is handling all the netconf sessions. So for netconf, you always have to be connected all the time in order to receive notifications. So the session handler has a task to handle a lot of these netconf sessions all the time. On the left-hand side, there's something we call an, RPC handler, a gRPC handler. So this is the one which is actually receiving the commands and is implementing the device management interface. We have something called a gRPC client. This is not something fancy, but this is what we are using for manually testing the OLT device manager. And this is also what I will be later using for demonstrating how it can be used. Then there are things like an alarm handler, which is receiving alarms or events, as they are called, for the device management interface from the OLT, and the alarms are forwarded to Kafka. Then there's a process which runs software updates for OLTs. Then we have a process which collects metrics. So this is the performance metrics data collector. So this is doing, so you can configure metric data, and you configure the interval when they shall be collected. And so this collector is doing this for all the OLTs and then pushing the metric data to Kafka as well. The software update manager will also push events to Kafka. This is something we haven't implemented yet. So there you can see how the update process is running or was running in the history. And then, as I said, we want to use etcd to store the configuration. And then there's something which is currently in gray, which is a configuration manager. So this could be responsible for configuring OLTs. I think the only example currently would be, for example, configuration of logging. So log destinations, protocols, or log levels. This could be done by this configuration manager, which is not yet existing. By the way, if you have any questions, so just shoot. So if we look how this would be integrated with SEBA, I think this is very much, it's not that much related to SEBA. So I think NEM would be probably the one who is using the gRPC interface to talk to the gRPC handler. And then I think we are using Kafka from SEBA to push events. And we also would use etcd from SEBA, but at the same time, so etcd from Volta, I think. But at the same time, this could be any Kafka, any etcd. And it doesn't have to be NEM, it could be anything. So it's, as you can see here, there's no Volta, no owners. So it's just like a sidecar doing something. Now coming to the interface, as you know, there are several RPCs. Currently, we have implemented, I think, mostly all RPCs, with one RPC which is not implemented. So for device management, we have a start and stop of managing of a device. You can get the physical inventory. You can get the hardware component info for specific hardware components. What we do not support is the setting of hardware component info, which means you cannot actually configure something using that interface. I'm not sure what the use case would be for that, so it's also really not planned to do that for the time being. Then for events, you can list the supported events. You can update event configuration, which means you can specify which events you want to see pushed to Kafka. And on the right-hand side, you can see the list of events which are currently supported. So we support PSU view failure, fan failure, and when the hardware device gets too hot, so when it goes above critical or even fatal temperatures. Then we have metrics. You can list the supported metrics. On the right-hand side, again, you can see the metrics which are supported. So it's inner surrounding temperature, CPU usage, RAM usage, disk usage, power usage, and fan speed. You can update the metrics configuration, which means you can specify which metrics to collect and at which point in time. And you can query specific metrics manually. And then finally, there's software management. So you can query the software versions which are currently running on an OLT. You can download a new image to an OLT. You can activate an image, and you can revert to a formerly activated image with revert to standby image. Are there any questions for that? Otherwise, I would just head over to the real test. Okay. The test is running on a Linux host we have in our test lab here in Berlin. As you can see, there are 3 virtual machines. We have Kubernetes, which is forming a cluster of these 3 machines. We have 1 master and 2 worker nodes. On Kubernetes, we have several pods running, and one of these pods is the device manager pod. Then we have an Azure OLT, which is actually running in Huntsville, Alabama in the United States, and it's connected to the Linux host via our corporate network using simple IP. Okay, then I will show you how this. So I'm now connected to our Linux host, and can you still hear me?
Yes, perfectly fine.
Okay, fine. Yeah. So I had some problems with my my audio system yesterday, so I was asking. So as you can see here, we have several pods running. We have set up our system using, an automatic approach using Vagrant and Ansible, and then we are using kind Walther for setting up Walther and owners, and etcd and Kafka. Then we have used Helm to set up an Atron OLT adapter. Also the ONU adapter are set up using Helm afterwards, and then we're using Helm to set up the Atron OLT device manager. So I did this before, so you can see it's now running for 2 hours. As I said, we have something called the gRPC client, which is also part of the Docker image. So I will be using that for testing this. As I said, Volta is running, so you can also see that we are connected to an OLT with this IP address, and this is active, reachable, and also the ONU is active and reachable, and the initial MIB download was successful. I just grabbed one OLT testbed of our, so we have a common resources of testbed in Atran, and I just grabbed one, and that's the one. I didn't do much testing, and I'm not the Volta expert, but I hope that this is okay. How it looks currently. So the gRPC client is running in our pod. So I have to enter the pod using and start a shell within the pod. Then you have to know the IP address of the OLT, and you have to specify a name. And I'm just using variables here which already contain the IP address. As you can see here, this is the IP address and the name I'm going to use to make the test a little bit easier. I also set the UUID here. Normally you will get the UUID later on. I will show it to you, but anyway, I'm setting it here. Okay, so the first thing you have to do, you have to, oh no, I'm doing something different as well, sorry. As I said, there's Kafka, and we can push events to Kafka, and we also have our client to output received Kafka events. And I will just start Kafka consumer here. This Kafka consumer is actually listening for two metrics. So, by the way, is this big enough? I hope so. So
it's pretty good. I think I can see it.
Okay, yeah. I have to apologize. So, I mean, this is really not made for demos. This is, as I said, more meant for our internal testing and whatever. So, but I think we're all developers, so I hope this is okay. I mean, there's no GUI or CLI for that device manager, so this is all we have. So, as I said, we're subscribing for two topics. One is DM metrics for metrics, and one is DM events for events. There's also one for software update information, but as I said, it's currently not implemented. Okay, then I have to do a so-called start managing device. So, as I said, this is a gRPC client. We are specifying the IP address and just to give a name, and then we call this start managing device, and the gRPC client then internally creates a gRPC message or a protobuf message and sends it via gRPC to the OLT with a given IP address. Okay, so in principle, you can see here, this is the content of the protobuf. So this is basically, there's a field called URI where you add the IP address, and then we have the name here. Then you can see that it was successful. There was no error returned, and you can see that the UUID was returned. And this is, or should be, actually the same UUID I specified here before. And this UUID is really important because the UUID is then used for everything. When you want to address a specific device, you have to specify this UUID. So, for example, I could now query the software images which are on that device. So it gets software version, and I have to specify the UUID here again. Okay, we can see that we're getting two things back. One is the active version. This is called, so this is an actual internal name, SDX3320, just a number. And then we also have another version which is with a different name. So this is the active version, and this is the standby version. So we have two partitions, and the active is currently running. You can query the physical inventory for this device. This looks a bit weird. Give me a second. Okay. So you can see here, this is all the inventory. So this lists several types. It lists the CPU. You can see storage resources and everything. So everything is listed here, and everything has a UUID. So in order to get more information about something, for example, the CPU has sensors, and you could query the CPU usage percentage, for example, then you have to specify the UUID. And I mean, this is already pretty printed in protobuf. It looks a little bit messier, but in general, we have, can you see PowerPoint again?
Yep.
Okay, so we are using the following structure. So we have a chassis, then we have main 0, and then you can see components for CPU, you have storage resources, you have RAM, temperature, you have fan cages, and then you have fans inside of these cages. We have power supplies, you have transceiver cages where you have plugged in transceivers. And here's an example for temperature. So you can see temperature is a sensor. There's a description. So the parent is listed. There's a UUID. You see an upper state, and then you see the sensor data. So you can see here that the temperature is 52 degrees Celsius. The sensor is okay. The units are Celsius, and all this is shown here in this for all we have. But you can also just get one. For example, you can get the the temperature. And here I have to specify the component UUID. This is unfortunately different for every OLT. There's a temperature sensor. This is a UUID. Oops. Paste this one. Okay, for example, this is now only done for the temperature, and as I said, we support several metrics besides, so you can, no, it's not a metric, sorry, it's a hardware component info. So you can see these, you can query these manually, and there are events, so you can list the supported events. Again, this is only protobuf, so it's not that easy, but you can see it's temperature above critical, above fatal, PSU failure, fan failure. And if we look to Kafka, we can see that, I can perhaps first show you metrics. So we support several metrics. These are the metrics which are supported, like RAM usage, power usage, and so on. And you can actually get the metric as well. So, for example, for the inner surrounding temperature, we'll get metrics for that. So you can see it's 54 degrees Celsius. And there are around, I think, 6 metrics which are currently supported. I don't know, the fan speed, for example. So this is the value for the fan speed. So this is for getting metrics manually, but there is a default setting so that metrics are automatically collected and pushed to Kafka. And here we can see in Kafka that this already happened. So you can see it for all the fans, or it happened several times already. So this is part of Kafka. Then with events, we can, or alarms, we can, what I will do now is the gRPC client will set the level for the temperature alarm to a very low temperature, I think 10 degrees Celsius, and then we should be able to see an alarm, and then we are setting the threshold up again, so we should a clear alarm for that in Kafka. And okay, you can see that we can see that there's an event happening that the temperature was above a critical level because it was above, as I said, 10 degrees Celsius. Okay, then I think the final thing I want to show is the software update. As I said, there are currently 2 software images installed. This is currently the active one, which is called 1207, and then there's in the standby partition there's an image called 1050. And I now want to install an image which is called 1172. So there is a download image RPC, and I'm using 1172. And you can see that there are several responses sent via a gRPC in the stream. So it says copying image. So you know that that the image is currently copied. And then eventually it should say that the download was successful. So it's now copying. So the
Holger, what's the size of the image?
Sorry, what?
What's the size of the image?
To be honest, I don't know. So it's loaded from an internal FTP server. It's not so, and the FTP server is not part of the device manager. This is somewhere in our corporate network. So
and the image is fetched from that server, right?
The OLT is directly fetching it from the server.
Fetching,
so
okay.
The device manager is only telling the OLT which image to use and from where to get it, and then the OLT is automatically fetching it.
Okay.
So here you can see that the it says upgrade complete, which means that it's uploaded, not yet upgraded. So now we can see still have the 1207, but in addition now we should have here it is 1172. So we had 1050 before, now we have 1172. And now we could activate the image. This is a simple command. It will only activate the image in the standby partition, so you don't have to specify name or something. You just do activate image. Okay, now it says installing image, and then it says rebooting device. And now we have to wait until the device has rebooted. And the little showstopper here is that it takes about 8 minutes. So, and this is basically also the end of my presentation. So if we can fill the 8 minutes with some questions, this would be great. Otherwise, I think I could show you afterwards that that the update happened. We could look into water. What does one think? Okay, it says unreachable now for the OLT.
And that is because it treats it as a reboot, correct? I mean, it brings it down. It kills the equivalent of the channel to adapter, and the adapter says I cannot reach it anymore, so it reboots, and it does the same as an OLT reboot, correct?
Yeah, I mean the reboot is triggered by the device manager, not by the adapter. So the adapter is only seeing that the IP connection is not there anymore. So I mean our OLT adapter is also using netconf, and the netconf connection cannot be set up. So it terminates, and then it tries to set it up again, which it cannot currently because it's booting, and that's why the connect status is unreachable.
Okay.
So the adapter is not rebooting. I don't know. I'm not sure if you meant this, but this is really done by the device manager. But in principle, when the update is finished, then we should be able to see the OLT again in Wolfer. And we can look it up, but as I said, this takes still 7 minutes, I guess. So
that's fine.
Yeah.
So another question is the CLI that you have there. That is just dependent on the DMI, right?
Yes, yes. So this could, in principle, be used for any.
Okay, that's interesting.
Yeah, it's not really that nice. So currently, I mean, it's pretty simple, and yeah, I mean, we could share it perhaps. I don't know. It's
would you? Yeah, exactly. That was my follow-up point. Would you mind upstreaming that? Is that something that you can do?
Yeah, I guess we can do. But I think if we are going to do this, then perhaps we should make it a little bit nicer, perhaps. So, but yeah, we could do this.
We can collectively work on it. It doesn't have to be you to make it nicer. I mean, you can upload this first draft, and if anybody uses it and feels that he wants to make it nicer, he's free to do it. If there are some things that you clearly feel that you would like to change before upstreaming it, that would be for sure up to you. But in general, I think it's a valuable thing to have.
Yeah. I think we can do this. Yeah. I mean, I would like to clean it up a little bit. I mean, it's a tool for testing, and I mean, you normally put much effort in the testing tool. That's why it might benefit from and some cleanup.
Well, to me, there's two things there, and then I'll come to a few other points on the demo, which was great, by the way. The first is, this is to me really a CLI. It's not really the testing. The testing infrastructure needs to kind of be different. It can use this, but it doesn't have to be within this. To me, this is more akin to what VoltCTL is.
Yeah, but it's not. Yeah, but it's in principle you're right, but it's some parts are hard coded, and so it's not. And there's no help and whatever, so it's not easy to use. It's but we could think about it. Yeah, sure.
Okay. And again, if it's something that we can help with, we do as always. We upstream the code and we merge it, and then I can help with adding an help or removing some of the hard-coded stuff, or somebody can come in and do an output to JSON or things like that. Yeah, we can take this offline maybe, but I just made a note that I think it would be very useful, because it's something that you have, and it would need to be built at some point, I think, to use the interface. So you already have it. Why do we need to build it again?
Yeah, sure. Yeah. I mean, it could perhaps be a good idea to use the generated Python code to create a client, because then you're testing Python code and the generated Go code at the same time, probably. Which, but anyway, yeah, we can discuss this. Yeah, sure.
Yeah, we can discuss this. I think that the CLI, I would still go with the Go because it's simpler. I like it better than Python.
Yeah.
But the tests, the robot tests, are actually going to be in Python, so we're going to test the Python generated code.
Yeah. Okay. Yeah, you're right.
Regarding the demo, this is great. There was a lot of things that you showed, and all of them were very nice, and it was precisely what I think was the point of the interface, doing the kind of operations that you have done. So to the things that you have showed, this is great. I mean, it proves that what we have created works, and it shows that it's a fairly simple and straightforward, but yet powerful interface. The one thing on the things you said in the presentation that I wanted to touch upon is that you said that you didn't see the use for the set component info. But for example, something that I personally feel could be very useful and a clear example of how one could use that API would be the capability to set the fan speed. I don't know if you have this capability within the Adtran OLT, but at ONF we have been fairly. It would have been very useful to us to have that capability to set the fan speed, especially during like times where the server room was at higher temperature, or we needed to do like a recording in the server room, and we, instead of shutting down all the machines, we could have lowered the temperature. That's a clear use case to me. Lower the fan speed, sorry, not the temperature. So that's something that I would have, that if you guys have the capability to do on your OLT, it would be good to have as a first example of the set component. Make sense?
Yeah. I actually do not know if we can do this. I mean, if it's configurable, but yeah, we can check this. I mean, the only problem with the interface currently is that there's quite a lot you could, in principle, configure. And I mean, this also has to be stored in the database so that after reboot, the configuration can be done again. And so this makes things much more complex, I think, on the OLT side.
Indeed.
Yeah, on the device manager side, and
yeah.
It introduces also some problems you can have, and normally I don't think that this should be the way to configure something. I mean, Volta or the adapter is used for configuring the PON part, and you shouldn't mess with this here. So
no, absolutely not.
Yeah.
I agree.
So,
there's only a few things that I want here to be configurable, and those are not the Volta related components. Again, fan speed, LED, or I don't know, you want to manually set the power adapter to off. This is the place to do it. One of the two power units, you want to set them to off, and you have that capability within the box. This is the place to do it. This is just pure box management. We don't want to touch any Volta related component. But that's I think it's a next step. It doesn't have to be here, and the demo you showed is great. So this was just purely comments.
Okay. Yeah. Thanks.
I want to open the floor to anybody else. Does anybody have any questions before Holger shows us the updated image?
I am wondering about the use of UUID. Do we have to set it for the connection, or is it just for the correlation purposes of alarms and events, etc.?
It's I mean, the UIDs are used for everything. So if you look, I mean, you have to use the UID for identifying the device. For if you want a software update, for example, you have to use the UID of the device, and this UID is generated out of the serial number of the device. But also in alarms and everything, you will see the UUIDs of the components which are sending the alarm, as you can
So is
see
it the
here.
same with the Volta device ID, or is it something else?
No, this is a different UUID.
Yeah.
We could look at possibly correlating it. That's not a bad idea, actually. But the problem is that depends on the implementation. It's a suggestion that we can make, but it's not, the interface cannot mandate that. But it's a good suggestion to make. So I'll take note of that. And maybe if we don't have time today, we can discuss it next time. But the UUID correlation between Volta and the DM manager would be very useful, I think.
Yeah.
Yeah.
So, but it's just a unique number right now. Is that correct?
Yeah. So currently, we generate one. So Robert, please correct me if I'm wrong, but we generate one UUID for the device, which is based on a serial number, and then we use this UUID and generate all the other UUIDs out of it. So by using, we're using basically the one UUID, and then we add strings for all the names, and then generate a new UUID always. So there is a system.
So if I said it wrong, I wouldn't be able to connect it, right?
Yes. I mean, I mean, what means connecting? I mean, there's one command which is called start managing device, and in the start managing device, you provide IP address and a name, and then you will get a UUID back. And this is UUID you have to use for all following commands. So you have to somehow remember this in your system.
Okay.
I think there will be a new command, get, Amit, you're also on the call, right? And so you can get the, so I think there's a new command for getting the managed devices, and you can get then the UUID back with this command as well.
Yeah.
Okay, yeah. So, but you have to use this UUID, and this is a little bit, I think, complicated, and it also means because we're generating the UUID out of the serial number, and we're not passing the serial number as a parameter to the start managing device, so we have to wait until the OLT actually is connected to the device manager in order to get the serial number. So we cannot generate the UUID in advance, which means you are not able to execute any command, even if it's not required to connect to the OLT. I mean, if you just want to configure something, you could in principle configure it on the device manager, and then when the OLT finally connects to the device manager, then the device manager is doing the configuration, which was just stored before. But this is even here not possible because it has to be connected at least once. I mean, and normally this is probably not an issue because your OLT will connect once, and then it will be the same UUID for this OLT for a very, very long time. So this should be okay.
But in theory, you could still pass the serial number if you have it, and that would be generated by the device manager adapter. It would auto-generate the UUID based on the serial number. So if you have the serial number, which I expect the operators' systems and like inventory to have, I think once you have the serial number, you could pass it in and generate the UUID out of that.
Yeah, I mean, we could think about it, perhaps another RPC which will just return the UUID based on the serial number you pass, and you could generate it all the time. So you could do it before or whatever. So yeah,
that's an interesting point.
Yeah. But anyway,
sorry, I'm missing the point here. So my thought or my understanding out here is that we need an ID to identify the device. Similarly, we need IDs to identify uniquely each of those components within a device. And if you can get an ID which is unique across the system, right, then all the more better. And so that's why UUID has been chosen as an implementation for the IDs, because it gives us a unique thing within the system, right? So as in, that's my understanding.
Yeah, I mean, UUID is good, but why not be able to just generate the UUID and not wait until the OLT really connects? I mean, if you have the serial number already, then you can just generate a UUID and you could configure,
So see,
for example.
the only requirement here is that, okay, there are two different things, right? One is the ID. UUID has been chosen as an implementation for the ID. But the requirement is that the ID should remain constant across reboots of the device, right? That's the only constraint. So as long as that can be guaranteed by the device manager, there's no requirement that you need to use the serial number to generate the ID. It could be anything. As long as you guarantee that once you have allocated an ID for a device, that's going to remain the same across reboots of the device. It could be anything that you could use to generate that.
You only pass an IP address and sorry,
Or
my telephone. Just a second.
whatever. Yeah, you could pass whatever seed string you want. Right, Amit?
Yes.
You could pass in.
No, so what we are passing, right, or what is being passed in the Start Managing Device API is some information of how to connect to the device or where the device is located, right?
Yeah.
But that doesn't say that this is what you need to use to generate the ID of the device, because being the device manager, you know much more about the device than your outbound systems.
Yep.
Yeah, I mean, yeah, but only after we have connected to the device. I mean, we don't have much information about the device, and just providing the serial number to the device manager could be a way to do that. But yeah, I mean, it's working. I mean, it's working. It's just yeah, you have to store it and you have to, which might be fine. Just,
yeah. What happens with that is right now, what happens with. So if you look at both the parties on either side of this interface, right? So you have the device management interface. The user of this interface is basically trying to manage devices. And on the other side, there are devices, right? So you have a device manager who is implementing this interface, right? But the user does not really know if this interface is being implemented by a manager or it is really the device itself. But the suggestion that you're making that if we should be able to pass in some data before we can really connect to the device forces the user of the interface to understand that there are two separate concepts out here. One is the manager of the device and the second is the device itself. So we bring in one more concept into the equation then. So yeah, I think we can
maybe let's why don't we do this? Sorry, Amit, go ahead.
So I think one of the suggestions that is being made, right, that we should be able to correlate somehow the ID of the device at Volta and at the device manager. I think that would definitely be of practical use. This can be done by the components sitting on top of either of those, but yes, if that process can be eased by the implementations, I think I would be up for it as well. So, so for that, I think if we have an option of the user itself passing in a ID, right? So in the Start Managing Device itself, it could pass in an ID saying that use this ID for the device, just a suggestion, right? And it would make things much more easier to do the correlation. But the device manager could always say that what you're passing does not make sense to me and return an error. So for example, if he's passing the same ID multiple times.
Yep.
Okay, let's do this in the interest of time and to conclude the demo. Let's finish up the demo. and let's take discussion about this next time. Given that we can discuss this and the remaining topics next time of the call. So Holger,
okay,
please do.
Yeah, I will. So as you can see here, so we have now several responses. It was installing and rebooting before. Now the image is automatically committed by the device manager, and then it says activation complete. And you can see, then I also did a get software version again, and you can now see that 1172 is the active version, and the 1207, which was active before, is now, this 1207 is now the standby version. And I really hope that when I now switch to Wartha and run that command again, okay, I can see that now the device is reachable again in Wartha, and even the ONU is should be fine. So the software update didn't break anything in Wartha. Yeah, I think that's all.
It's great. Did you try adding a subscriber to make sure that the ONUs go to flows pushed state too?
No, sorry. As I said, I don't know not much about Wartha and anything, so I didn't do anything, and I even do not know what exactly our testbed has connected to that ONT, and if this is that simple. Yeah,
that's fine.
I just grabbed one OLT and yeah.
Mm-hmm. Okay.
Yep,
thanks.
for me.
That's great. Any questions for Holger before we finish our call? No questions? Okay. Then we had another group of topics for today about the implementation on BBSIM and the logging and things like that, but I don't think we can get to them right now because especially the logging part will be a heavy topic. So what I'm thinking is that I might call one-off meeting next Thursday, so we can get to some of the topics we didn't get today. Would that work for everybody, or would that be too much?
It works for me.
Okay. Then I'll call for an extra meeting next Thursday to discuss the things we didn't get today, the UID, the device this, and the logging, because we do have, I think in the 2.6, a target to include these three things, especially the open source here version and the logging for the OLT box. And if we can get those, that would be great. So I'll call the meeting and send out the invite to everybody as soon as this call has finished. Any questions before we finish? No? Okay, then if not, thanks everybody for joining. And thanks, Holger, for the demo. It was great. And thanks for the whole team that worked on this. And was great seeing this in action. And it worked flawlessly. So kudos to you and the team. It was great. So
thank you.
Let's discuss upstreaming the CLI, even with some changes. And we can take that offline. Let's continue the great work, and I'll see you guys next week. Thanks, everybody.
Thank you.
Cheers.
See you.
Thank you.
Bye.
Bye.
Bye-bye.
Bye.